we are doing this transformation from time to frequency. Then instead of looking from here, from this side, you start to looking from this side. In this side, each time waveform can be represented by one line, just one line, and amplitude. Then, in this case, this one line at certain frequency, which representing the defective part, and the amplitude representing the severity. And of course, all of this has many details we can know in the course. To make the right measurements, we need to use the proper sensor. That's can be represented by having three types of sensors. One called proximity probe, the velocity probe, and accelerometer. But first of all, we need to know what types of vibration measurements we have. We have two main types of vibration measurements. One is the absolute vibration. Second is the relative vibration. For absolute vibration, we are measuring the overall vibration for all the machine. Okay? But for relative vibration, we are using proximity probe to measure the relative movement between the shaft and housing. Then, in this case, we consider housing as a reference point, which consider like 0. It's not moving for these sensors, but the measured vibration is the only shaft vibration, not the whole body vibration. That's why sometimes we need to measure in both relative vibration and also measure the overall vibration or absolute vibration, because each one of them can gives me indication about certain defects. Why I'm using two probes? I'm using two probes to one of them consider like redundant to the other, and to draw this orbit, because without using two probes you can draw the orbit. What the orbit? Orbit is the location of shaft center line. Can use these techniques for detecting also many defects, and using this orbit analysis technique have many things and many benefits. Especially we talk about journal bearing or oil film bearing. You use only this orbit as a good indication about defects like unbalance, misalignment. Many kind of techniques, many things we can detect using this orbit. We can also know about this in course. I'm taking the measurement in 3 direction: X, Y, and Z. In these 3 directions, to detect all the movement or all the forces affecting this machine, make it vibrating. These some example of faults can be detecting using vibration analysis. Main things like we said before, like mass imbalance, bend shaft, misalignment, and so on. Many things. Of course, we are using two main types of measurements. One we called offline, and second one we called online. Online, I don't know about time, Mr. Khalid. Okay. For online monitoring, you can monitor the machine live, the live machine, about the value. Even sometimes we can add systems to monitor the spectrum itself and time waveform and make the analysis live. But normally, and the most common one, is using the offline device. Like you have this device, portable device, go to site, take the vibration measurement over the machines, and after that download this or dump this data to system. And this system is PC based software, And this software gives you storage capability, give you analysis capability, gives you historical readings you can refer to when you have some issue in the machine. Then you can get the reference, you can do the analysis, you can do reporting, you can do everything using these softwares. And of course, using the online is a good indication. Also, you can setting the online for alarm and trip in order to protect your machine. Then the question here, how can we make reference when I'm saying this vibration is good, when I'm saying this vibration is not good? According to what? According to what? We have many references. One of them is the ISO standard 10816. Okay, this standard gives you good indication about the machine condition, starting from the new machine end up to this red level that the machine should be stopped immediately due to high danger or alarm. Then it divides this machine according to the power. As you see here, groups, group 1, 2, 3, 4. The group 1 is a big one, starting from 300 kilowatt up to 50 megawatt. Group 2 is smaller a little bit. 3 and 4 is a smaller one, is up to 15 kilowatt only. Starting from this blue color, once your reading is in this blue area, which means you are in a good condition, it's considered like newly commissioned machine. But when the vibration level comes in this green area, this green area unrestricted long-term operation. That means you can run the machine under this vibration level for long time without any kind of restriction, which is of course acceptable. What if the reading in the yellow area? In this yellow area, that means restricted long-term operation, or you need to monitor this machine because the vibration level is a little bit high and it's about to be danger. So you need to make sure that you are monitor this machine close enough to detect the failure before it comes in red area. Once it comes in red area, that means you need to take necessary action because in danger right now. This machine could fail anytime. Here we found the standard code is come with the millimeter per second and also per inch per second, because we have many units for measuring vibration. And of course we have three categories. We have displacement, velocity, and acceleration. We can measure the vibration using these three values. Each value of this can gives us indication about certain failure. Like for example, when I'm talking about gears and bearing failure, we're measuring this part using acceleration. But when we talk about unbalanced, misalignment, other faults, we take the measurement using velocity, we using displacement, and so on. It depends on the range of frequency. You remember when we said here, this frequency. The defects generating frequency. Some defects generating very high frequencies and some defects generate low frequencies. The high frequencies measured using acceleration and low frequencies is measured by using velocity and displacement. Okay, and also different if you are measuring using peak or peak to peak or RMS, also different from type to type, and what type of defects you need exactly to monitor. Like an example of the failure, like unbalance. As we said, the unbalance is the changing between the CG and geometrical center line, and this change happened due to unbalanced mass. This unbalanced mass could be due to accumulated mass, like in blowers. If found the dust is accumulated by time.